Why are all rockets mostly the same? Why is there a big first stage that does a lot of the work and a lighter second stage? So commonplace in rocket design, why is it difficult to make rockets that stage at a low enough altitude to be reusable? How and why was the space shuttle a notable exception? Why does reusability depend on the speed at which a rocket re-enters the atmosphere? All rockets have linked constraints on weight, power, speed, fuel, and a few other factors. If rocket design is so tightly constrained, why do I think Starship will fail? On several occasions, I've criticized the design parameters chosen for Starship. The other side of that coin is that Starship is actually a pretty good design if your goals were to fix what was wrong with the space shuttle. The space shuttle had many of the same design goals as Starship and missed them by miles. The space shuttle survived missing its specs by such a large amount because it was the Cold War. The Russians were impressed, and Congress was willing to write the checks. Space shuttle reusability cost an insane amount of money because the amount of refurbishment required between launches. Starship design is at least logically consistent with actually achieving rapid reusability. However, as much as they fit together logically for the factors in the overall goals, the individual factors in Starship design, like catching a rocket using robot chopsticks, sending up a fleet of starships to refuel one in orbit, hot staging a supposedly reusable booster, making a rocket engine with the highest chamber pressure of any rocket previously designed, or putting your control surfaces where re-entry heat can melt them, or any of a half dozen other intentional risks. These risks have a multiplying effect, raising the odds of failure. Not only that, when you squeeze one factor, another pops out. Recently, SpaceX showed they are putting a liner under the heat shield on parts of Starship. That reduces risks for re-entry. But it also reduces payload, which reduces the chances of successfully refueling in orbit. It's also a kind of technical debt they're going to have to deal with later. It's bad enough that the odds of failure multiply, but they're also linked.